Hey y'all, this lesson is on multiplying integers. So this also actually includes division. Division is technically multiplication of fractions. So division is multiplication. Multiplying integers. Same rules apply as division. I already mentioned division was the same as multiplication. It's multiplication of fractions. You can think of multiplication as the word of. So I'm going to take that down. If I see 2 times 3, that means 2 rows, kind of, if you think of like an array or a rectangle or something, 2 rows of 3. And we're going to go along with the theme of my addition video where we use the bubbles. So to draw 2 rows of 3, this is 2 rows. Rows go side to side like in a movie theater of 3. 1, 2, 3. 1, 2, 3. They are all positive. So this is 2 rows, 1, 2, of positive 3 bubbles. Do any of the bubble, there's not really going to be any like popping of the bubbles because we're not adding. We're basically just going to be totaling. So when there are 2 rows of 3, how many bubbles are there? There are 6 positive bubbles. You might also see this in a rectangle. 2 rows of 3 positive. That's fine too. I just like bubbles. I think they're cute. So we're going to take that and fill out this table, which is similar to the table we filled out for adding integers. This one, number 1, says 2 rows of -3. So 1, 2, 3, negative, negative, negative. 1, 2, 3, negative, negative, negative. How many bubbles are there? -6. So I'll just kind of simplify the observation. You can word this in something that makes sense to you as you look back at your notes. I'm just going to say positive times negative gave us a negative answer. I'm going to be paying attention to the signs. In this case, not necessarily, weight doesn't necessarily pay, what's the word? Doesn't have any, I can't think of the word. Contribution to the answer. I can't think of the word. I'm just going to say contribution. I do numbers, not words. No. The weight of the numbers didn't really play into it. So it was more about the signs of the numbers. In number 2, I'm going to actually use the commutative property here. First, I'll show you a different way, but I'm going to start with the commutative property. The commutative property states that I can change the order of multiplication. And I want to point something out here also that I did on accident, but it's just kind of a habit. You'll notice that I didn't put a sign in between my parentheses. When there's no sign in between the parentheses, that means multiplication. So this is saying 3 rows of -2. So I'm going to draw that. 3 rows of -2. Negative, 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 negative. So there are 1, 2, 3 rows of -2 bubbles. How many total bubbles are there? -6. So even though in this first example the 3 was negative, whereas here it was positive, our answers were still the same. So that kind of shows that the weight, so that means like the 3 is bigger, doesn't necessarily play a role in it. It's just basically how many negatives are in there. So I'm going to do another observation. Negative times positive is still negative. And again, you can put that in your own words if you want to. Next page. You might pause it and try these on your own first and then hit play to check them. This is 3 rows of -4. 3, 4, 1, 2, 3, 4, all negative. You could use a different symbol on here if you wanted. You can even color in the bubbles if you wanted to make them, you know, the colored in bubbles are negative or whatever. So I have 3 rows of -4, which means there's a total of -12. So what is 3 times 4? And then how many negatives appear in this problem? So that negative kind of overtakes, which means that my observation still stands. Positive times negative is a negative. Whoops, that was an accident. Okay, oh, I forgot. In the previous page, I told you I would show you another way to do it, and I forgot. So I'm going to show you on this one. On the previous page, I used the commutative property, which means I changed the order. That means you can change the order of multiplication or addition, and it's still the same answer. So that's called the commutative property. Instead, on this one, I am not going to use the commutative property. I'm going to use the distributive property by kind of pulling out that negative from the 3. So this is -3 rows of 4, which kind of seems weird, but just bear with me. So 3 rows of 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. They're all positive. You could leave them blank if if you did the colored ones in for negative and the blank ones for positive, that would be fine. That way you don't have to draw those little positives. So I do have the 3 rows. I do have of +4s, but this negative has to play into the answer. So outside, I'm going to put a -1, which means that I'm going to multiply whatever my answer is by a -1. So that ends up being -1 times 12, which is -12. So that's just another way to look at it. I kind of think the commutative property is a little bit easier, but you can choose which one makes more sense to you. It doesn't matter to me. But in either case, negative times positive gave us a negative answer. So again, weight doesn't necessarily play a role. This was a -4 and the answer was negative. This was a +4, but the answer was still negative. So just because the 4 is positive or the 4 is negative, that didn't make a difference in the answer as far as the weight of it being bigger. So when we added integers, that did matter. The negative or the larger sign number outweighed the bubbles that popped, and that's what you were left with. In multiplication, that's not the case. The case is that how many negatives are there? If there's one negative, then it makes the whole answer negative. Now let's look at number 5. I have -3 rows of -2. So I can use that thing I showed in the previous example where I pull out that negative so that instead of -3 rows, it's just 3 rows. Not that it really makes a difference, but we'll just go with it. 3 rows of -2. So 3 rows of -2. This is -6 bubbles, but there's a negative out front. And what do you remember about a double negative? Makes a positive. So when we have 2 negatives multiplied together, it's just like having a double negative, which changes it to positive. Isn't that so neat? So we can say in our observation, negative times negative made a positive. And you can see in the table that all of our solutions were negative except for the one with a double negative. Let's take that a step further. If this had been +3 times +2, we know that to be +6. So in the case where they're both positive, you also get a positive. So these are the only two cases where you get positives. If there's an even amount of negatives, so there were 4 negatives, negative times negative times negative times negative, that even amount makes those pairs of positives, and makes positive. I'll show you. So if I had -1 times -1 times -1 times -1, which is actually -1 to the 4th, -1 multiplied 4 times, this pair makes a +1, this pair makes a +1, which makes a +1. Should do this. There we go. So that's what I mean by multiplied an even amount of times, it creates those pairs of positives. If I had put one more in there, then my answer would come out negative. So the odd piece there at the end makes your answer negative. All right, that was a side trail, but I think it was worth it. Here's some examples I want you to do without bubbles. Pause it. When you're done, hit play and check your answers. You should get -24, 8, -12, -24, -20, -12, -30, +2. So we only had 2 positive answers. Whoops, there you go. Oh, it didn't stay. There you go. So there's those. If you need to pause it and check your answers, you can do that. I'm going to go on to the next page. And I have some division problems. These are actual division signs. I mentioned that division was multiplication of fractions, so I really want to show you what I mean by that. Whoops. If you have 35 divided by -5, you might see it that way, and that's okay. This is 35 times -1/5. So when you see this, it's actually this. I am not going to make you rewrite it like that. You don't have to know that specifically to do this. I just wanted to make sure to show you so that you knew what I was talking about when I said division is just multiplication of fractions. So we get here the same rules apply. We only have one negative, so our answer is going to be negative. And 35 divided by 5 is 7. Then number 2, 8 divided by 4 is 2, and we have one negative. Number 3, -6. Number 4, we have a double negative here, which changes it to a positive. Super simple, very quick. Okay, I have a bunch of examples down here. If you would pause it and try them on your own and then hit play so we can go over the answers together. There's a whole bunch of them. So you should get, if you're hitting play now, you should get -35, 50. I'm going down. I know it's the wrong order, but I'm just going down because that's how my brain works. -84. This was a big one, 9 times 10 times 6. You can do 2 at a time. 9 times 10 times 6. And then same thing here, you could do 7 times 9 times 7, or you can use the commutative property. Doesn't matter, you'll get the same answer, which is 441. Whoops, there you go. Sorry. Then we'll go over to the other side. Should get -54, 18, -96. Again, here, you can do 2 at a time. That's +60 times -8 is -480. Or you can change the order around if you prefer. And then last one, 36 times -2, -72. So there's that. I'll zoom out so you can see them all, maybe. I'm frozen. Here we go. It is not happening. There you go. Sorry, it's not working out for me. So there's those. You can check your answers if you want to. That is it for this lesson. I hope you enjoyed it. If you have any questions, please let me know and I'd be happy to help.